Hello, and welcome to Investigative Math. Today, we will be going over the 2019-2020 Kickoff Number Sense Test, problems 11 through 20. So let's get to it. Keep in mind, every trick used in this video will be explained in more depth in videos that I have linked in the description. So, for our first question, we have 85 squared. Now, we have a trick that we use for squaring numbers ending in 5. Remember, 85 squared is the same thing as 85 times 85. Now, this is similar to another trick that we know, or if you don't, again, I've linked in the description, called the bump it trick. So what you do, or first of all, to know we use bump it, our 1's digits have to add to 10, and our 10's digits have to be the same. So 5 and 5, those add to 10, and 8 and 8 are equivalent. So we know we can always use this for squaring numbers ending in 5, because like, say we had 65 squared. We know that our 1's digits are going to add to be 10, because 5 plus 5 is 10. And we always know that our 10's digits are the same, because, well, they're the same number. So anyway, this is how you actually use the trick. So first, you multiply the 1's digits. 5 times 5 is 25, and so you write that down. Now, this next step is where the bump it trick gets its name. You want to take one of your 10's digits, it doesn't matter which one because they're the same, and bump it up by 1. I'm going to take this 8 and bump it up by 1 to make it a 9. Then multiply that by our other 10's digit. So 9 times 8. 9 times 8 is 72, and we write our 72. So 85 squared gives us 7,225. All right, on to the next question. We have 4 ninths plus 2 fifths, and we need to make this a fraction. So our first step is to cross multiply. So 4 times 5 gives us 20, and 2 times 9 gives us 18. Next, we want to add these to get 38, and this is our numerator. Okay, and now to get the denominator, all we do is multiply our two denominators. 9 times 5 gives us 45, and so 4 ninths plus 2 fifths is 38 over 45. Also, keep in mind, I would be wary of writing down these numbers before you have both of them. So I would keep this 38 in your head before you write it down in case this simplifies. If you don't already know, on number sense, if you write an answer down, there is no erasing, and all fractions must be simplified. All right, so for our next question, we have 43 times 63. Now, this is kind of like bump it, and you might be able to see it. So with bump it, our 1's digits added to 10, and our 10's digits are the same. For 43 times 63, our 1's digits are the same, and our 10's digits add to 10. So, just like it would make sense, this is called the reverse bump it trick. And this is how it works. So first, multiply our 1's digits. 3 times 3 is 9, and we have to make sure to take up 2 decimal places. So we write 09 instead of just 9. All right, next, what you want to do is multiply the 10's digits. 4 times 6 gives us 24, and then you want to add the 1's digit. 24 plus 3 gives us 27, so 43 times 63 gives us 2709. Okay, our next question. We have 12 plus 13 plus 14 plus 15 plus 16 all the way to 18. Okay, so you might notice something, and that something is that this is a sequence where to get to the next term, you always add 1. And we have a name for this. Whenever you have a sequence, where to get the next term, you add a constant, in this case, that constant would be 1, that is called an arithmetic sequence. Arithmetic sequence. Okay, and so that's what we have here. So to find the sum of an arithmetic sequence, what you want to do is take the median, or the middle valued term. So in this case, the median will be 15, right? You want to take the median and multiply that by the number of terms in our sequence. So the median of this is going to be 15, and then we obviously have 7 terms. 15 times 7 gives us 105, so 12 plus 13 plus 14 all the way to plus 18 is going to give us 105. All right, number 15. The mean of the primes between 10 and 20 is what? So, if you don't know, the mean is the exact same thing as the average. So, this basically just comes down to finding all the primes between 11 and 20. Sorry, between 10 and 20 and taking the average. So, let's see. We have 11, 13, 17, and 19. Yeah, those are all the primes between 10 and 20. If we add these up, 11 plus 13 gives us 24, and 17 and 19 together gives us 36. So if we add those together, we get 60. Then to take the average, just divide by the number of terms, or 4. 60 divided by 4 gives us 15. So the mean of the primes between 10 and 20 is going to give us 15. Okay. Oh, by the way, if you didn't see what I did over here, you wanted 11 plus 13 plus 17 plus 19. I just grouped these together. So instead of doing 11 plus 13 is 24, and then adding 17 and then adding 19, I grouped them together. So 11 plus 13 gives us 24. 17 plus 19 gives us 36. And so together that gives us 60. This is called the associative property of addition. You should look it up if you haven't heard of it. It's pretty cool. Anyway, for number 16, we want to turn 8 1/5% into a fraction. So, our first step, well, if you've worked with percentages at all, you know that they're really 100 times their fraction, or their decimal. So, to get a better understanding, if you had like 50%, you know that's the same thing as 0.5, or 50 divided by 100. So, we have to take this 8 1/5% and divide it by 100, and that'll give us the fraction value. Well, this isn't in a very nice format right now, so what I'm going to instead do is change this to an improper fraction percentage. So 8 1/5 changed to an improper fraction. You do 8 times 5 plus 1. You get 41/5%. Now that it's in this form, we can easily divide by 100 by simply multiplying the denominator by 100. So 8 1/5% is going to be the same thing as 41 over 500. Okay, number 17. So we have 13 times 18 plus 42 times 18. This is a classic problem having to do with factoring, which maybe you've heard of factoring, maybe you haven't. It has a lot to do with the distributive property. So maybe, actually, if you're past 5th grade, you've probably heard about the distributive property. And basically the idea behind it is, if I have 5 multiplied by x plus 6, this is the example I'm going to use. I can multiply 5 by x, and then multiply 5 by 6, and then add them. And that'll give me an equivalent expression. So, what I'm going to do is take the inverse of that, and that's factoring. So if you notice, each of these have a common factor of 18. And so instead of multiplying our common factor throughout, I'm going to take it out. So if I take out an 18, taking 18 out of this expression, you get 13. Taking 18 out of this expression, I get a 42. And you can see that this is the same thing if we just use our distributive property again. If we were evaluating this, you would do 18 times 13, right? Like right here. And then 18 times 42, like right here. And then add them. So, now that you know that this is true, just evaluate what's in our parentheses. 13 plus 42 is going to give us, what, 55? Yeah, 55. And then we can use a different trick that I like to call double and half. Sorry, I'm kind of all over the place. Double and a half. So I can take half of one of our numbers and double the other one. So let's see if this makes sense. 18 times 55. In order to maintain an equivalent expression, I'm going to half one of these. So take the half of 18, I'm going to get 9. But to balance it out, because I still want it to be equivalent, right? I have to double my other value. 55 times 2 is going to give me 110. And now this is a lot easier to multiply, because I know 9 times 11 is 99. Multiplied by 10 is going to give me 990. Okay, remember, whenever you're doing these factoring problems, they're often coupled with a different trick that you have to use, and the hardest part about doing these is finding out what trick to use. Okay, for our next question, we have 45 multiplied by 55. So this is a classic example of multiplying two numbers that are equally distant from a third number. In this case, 50 is a number that they're both equally distant from. So when you have a kind of problem like this, these are actually pretty easy. These are easier than they look. You want to take 50 and square it, 50 because it's the middle number, and then you want to take the distance of each of the numbers from our middle number. So 45 is 5 away from 50, and 55 is also 5 away from 50. You want to take that number and also square it, and then subtract them. 50 squared gives us 2,500. 5 squared gives us 25. And then you just want to subtract them. So 2,500 minus 25 is going to give us 2,475. All right, we're almost done. Number 19. What is the smallest number that 42 and 60 divide into without a remainder of 0? Sorry, with the remainder of 0. Not without. With a remainder of 0. So this is basically the same thing as asking for the LCM, or the lowest common multiple. And the way we're going to do this is we're going to find the greatest common factor. So there's not really a trick for this part. You kind of just have to see if you can guess it and then check if you're right. I'm going to guess that the greatest common factor is 6. So the greatest common factor between these two is 6. Then when I divide out the 6, they shouldn't have any more common factors. So when I divide 42 by 6, I get 7. Divide 60 by 6, I get 10. So yeah, I'm right. 6 is the greatest common factor. So now that you have the GCF, right, GCF, greatest common factor, what you're going to do is pick one of your numbers. It doesn't matter which one, but sometimes a certain number will make your calculation easier. Pick one of the numbers and divide it by our GCF. I'm going to pick 60 because 60 divided by 6 gives me 10, which is a really nice number to work with. So 60 divided by 6 is 10, and then we're going to multiply that by our other number. So 10 multiplied by 42 is going to give us 420. Notice we could have just divided 42 by 6 and multiplied by 60. We're going to get the same answer. 42 divided by 6 is 7, and 7 times 60 is going to give me 420. All right, on to the last question. We have 2,203 multiplied by 279. If you don't know what this asterisk right here means, it basically means it's an estimation problem, where you have a certain error a certain range of error that you can have your answer within and still have it considered correct. So by no means, do not try to get this exact. You will take up all of your time and you probably will not get it right. So on estimation, especially on the first column, a lot of times this is just as simple as rounding. So I'm going to round this to 2,200 and not to 280. So whenever I'm multiplying and I have extra zeros, like on my factors, a cool thing I can do is just write them in my answer blank. Because this is going to be 22 times 28, right? And then multiplied by 1 10, 2 10s, 3 10s, because each 0 at the end of a number means multiplying it by 10. So that's times 10, times 10, times 10. And so if I'm going to have 3 10s multiplied together with my answer, then I know that I can just go ahead and write my 3 zeros. So now all I have to figure out is 22 multiplied by 28. Now you might recognize this from earlier in the problem, earlier in the test. This is bump it. Notice our 1's digits add to 10, and our 10's digits are the same. So our first step is to multiply the 1's digits. 2 times 8 is going to give us 16, and so that's what we write. We write 16. Now, if you remember, the reason bump it gets its name is we're going to take one of our 10's digits, and bump it up by 1. If you bump 2 up by 1, you get 3, and then just multiply that by our other 10's digit. 3 times 2 gives us 6, and so we write the 6. So the estimation I'm going to use for number 20 is 616,000. All right, and that does it for the 2019-2020 Kickoff Number Sense Test problems 11 through 20. If you need me to clarify anything for you, leave a comment, and I will get back to you as soon as I can. If you enjoyed this video and found it informative, leave a like, and if you really loved it, make sure to subscribe. I'll see you later.